Have you ever tried to get an AI to summarize a really long book, only for it to forget the beginning by the time it reaches the end? Well, today, we're diving into a breakthrough called Kimi Linear. It's a new kind of AI architecture that might just solve one of the biggest memory problems these models face. It's a simple question, right? You can read a novel and remember the plot from the first chapter to the last. But for an AI, that's an incredibly difficult, almost impossible task. So, what is it that's actually stopping them from just reading the whole thing and getting it all in one go? All right, let's get into it. The answer lies in something that researchers call the LLM memory bottleneck. And it all boils down to a fundamental limit in how even the best AI models today, pay attention. So, at the very heart of models like ChatGPT, you've got this thing called the attention mechanism. It's honestly a brilliant piece of engineering. It's what lets the AI figure out which words in a sentence are most important to other words, and that's how it understands context. It's what makes them so powerful. But it has a critical, and I mean very expensive, flaw. And that flaw has a fancy name: quadratic complexity. It sounds super technical, but the idea is actually pretty simple. Imagine you're in a meeting. For every single new comment someone makes, you have to mentally replay and compare it to every single comment that came before. It would get out of hand fast, right? Well, that's what the AI is doing. As the input, let's call it N, gets longer, the computational cost doesn't just grow, it literally explodes. And this is where the math just gets brutal. I mean, look at this. 2 words, 4 checks. Okay. 10 words, 100 checks. But 1,000 words? That's not even a full page, and you're already at 1,000,000 checks. You can see how this just isn't sustainable. This is the core reason why feeding a whole book, or even just a long report into a standard AI, is basically a non-starter. So, researchers knew this whole computational explosion was a huge problem. Naturally, they started looking for a faster way to do things. But, as it often happens in engineering, the first solution created its own difficult trade-off. That solution was called linear attention. So instead of that crazy n-squared explosion, the cost grows in a nice, straight, predictable line. It's way faster, much more efficient. So what's the catch? Well, the problem was it just wasn't as good. The models that used it were less accurate and kind of struggled with the nuance that makes the original full attention so powerful. And this really created a central dilemma for anyone building these things. You had a choice. You could have full attention, which gives you that high quality, but it's incredibly slow and expensive. Or you could have linear attention, which is super fast and efficient, but you take a real hit on performance. For years, you had to pick your poison: a smart but slow model, or a fast but, well, dumber one. So clearly, what everyone was looking for was a new approach, right? Something that could give us the best of both worlds. And that is exactly where the Kimi Linear architecture comes into the picture, with its really clever hybrid design. Okay, so at the core of this whole new system is something they call Kimi Delta Attention, or KDA for short. Think of it as a much, much smarter version of that old linear attention. It uses what the researchers call a fine-grain gating mechanism. So if the old models were like a student who could only remember to either keep or forget entire chapters of a textbook, KDA is like a top-tier student who knows exactly which words to highlight for the test. It gives the AI incredibly precise control over its own memory. So how do they actually build it? Well, the Kimi Linear model is basically a stack of repeating blocks. It uses 3 of those super fast KDA layers to do most of the heavy lifting, and then it's followed by one single traditional full attention layer. That top layer acts like a supervisor, making sure the model keeps the big picture in focus and the quality stays high. This simple 3-to-1 ratio is the real secret sauce here, balancing that speed and intelligence. All right, now for the really exciting part, the results. I mean, it's one thing to have a clever design on paper, but does it actually work? Let's look at the proof and see how Kimi Linear actually does in some real-world tests. So here we're looking at performance on the MMLU Pro benchmark, which is a really tough test of an AI's advanced knowledge and reasoning. And look at this. Kimi Linear doesn't just match the other models, it significantly outperforms them. This is the crucial takeaway. The hybrid approach didn't just make the AI faster, it seems to have actually made it smarter, at least on this really hard task. And then there's the speed. This number is just staggering. When it's generating text from a massive context, and we're talking 1 million tokens, that's like a really, really long novel. Kimi Linear is over 6 times faster than the standard full attention method. That is an absolute game-changing leap in performance. And on top of being way faster, it's also way leaner. Kimi Linear uses 75% less memory for its key value cache. That's basically the AI's short-term working memory. In the world of AI, memory is a huge cost and a massive bottleneck, so cutting that down by 3/4 is a huge efficiency gain. The researchers themselves, they sum it up perfectly in their report. They basically say that Kimi Linear isn't just some cool lab experiment, it's a practical, drop-in replacement for the systems we all use today, and it offers better performance and better efficiency. You can't ask for much more than that. So, okay, let's bring this all together. What does a faster, smarter, more memory-efficient AI architecture actually mean for the future of AI and for all of us who are going to use it? Well, ultimately, a breakthrough like this is a key step toward building what people are calling agentic AI. We're talking about systems that go way beyond just answering a single question. These are AIs that can handle complex, multi-step tasks, interact with other tools, and make decisions over long periods of time, acting a lot more like an autonomous assistant. In practice, this means we could finally have an AI that remembers an entire hours-long conversation from start to finish, or an AI that can analyze a whole software project to find one tiny bug, or an AI that can plan and execute a complex task for you. It takes that original problem we talked about, reading a whole book, and applies that kind of memory to tasks that are way more dynamic and useful in the real world. And that really just leaves us with a final, kind of provocative thought. For so long, an AI's poor memory has been this fundamental wall we kept hitting. Now that that bottleneck is being smashed, what new frontiers can AI help us conquer next? What problems, the ones we once thought were impossible, could we actually solve with an AI that has a near-perfect memory?